In problem number 2 on chapter 1 review, the first thing we see here is that we've got this negative exponent. If we have a negative exponent, it means we just flip this base, flip whatever's inside this parentheses, and then we'd have a positive exponent. So you'll see here that I wrote exactly what was inside. I just flipped. What was in the numerator is now in the denominator. What was in the denominator is now in the numerator, and it's now raised to a positive 2. We're now going to distribute this exponent, this positive 2, to everything inside here, which means we're going to multiply. So I'm going to do the positive 2 times this exponent 2. I'm going to do the positive 2 times negative 1/2. I'm going to do the positive 2 times this 1, positive 2 times the 3/2, and positive 2 times the 3. And when I do that, I get right here, all of those exponents have been multiplied by 2. You know, you have fractions. A negative 1/2 times 2 gives you negative 1, and 3/2 times 2 is 3. So we've got that going on. And now we've got x to the 4th divided by x to the 3rd. Well, if there's 3 x's down here and 4 x's on top, we're left with just 1 x in the top, x to the 1st. The other thing is we're just subtracting. 4 minus 3 is 1, so we have x to the 1st. With this one, this y to the negative 1, this means this y needs to be put down in the denominator. So you'd have y to the 1st, and you would add those exponents, and you get y to the 7th. And we have the 3 squared. So remember, a negative exponent is saying that I would have the reciprocal of this base, or in a fraction, I kind of say if it's a negative exponent, it doesn't like where it is. So take this y to the 1st power and put it down in the denominator. If I had a negative exponent down in the denominator, I would move it to the numerator as a positive. For 2b, we have, it's a subtraction problem, and we're just simplifying, so we need to get common denominators. Now remember that x squared minus 4 is x plus 2 times x minus 2. So I need to have this denominator be the same thing, x plus 2 times x minus 2. So I multiplied the second fraction by x minus 2 over x minus 2. Remember that we're going to now multiply x plus 1 times x minus 2, and we get this trinomial, x squared minus x minus 2. And we still have the x squared over here, and they're both over the same denominator, so I can write it as one fraction. We're going to simplify this, so x squared minus x squared, well, that goes away. This negative is distributed to that, so it becomes positive, and it's also distributed. Here we get a positive, so we have x plus 2. Since we now have x plus 2 in the numerator and x plus 2 times x minus 2 in the denominator, these two factors cancel. I'm left with a 1 in the numerator and an x minus 2 in the denominator, and here's the final answer. This is the corrected answer. I had originally posted a mistake. I'd done a little error there, but it's been fixed. So this is correct. For problem number 7, this was a problem where we're given this equation in general form, and it's a circle, and I know it's a circle because in front of the x squared is a 1 and in front of the y squared is a 1. Since those coefficients are equal, I know this is a circle. To write it into the standard form, where we can find the center and the radius, we have to complete the squares. So first of all, we put the two terms with x's in them together, and then we had nothing here. This was a blank. Okay, and then we had our y's together, and there was another blank here, and we subtracted the 6 right here in the equation. There's a plus 6. We subtracted it. That's everything I wrote in black. Now, in this group where there was a blank right here, I'm going to cover up that 9, I need to figure out what I would add to complete the square. So I take half of 6, which is 3, and square it, and voila, I get a 9. Over here, I take half of negative 2, which would be negative 1, and square it, and that would be a 1. So to complete this square, you need to add 9. To complete this square, add 1. If you added a 9 and added a 1 to the left side of the equation, we have to do the same thing to the right side of the equation. When I say that I completed the square, it means that now I have a trinomial that can be written as a binomial squared, x plus 3 quantity squared. And if you multiply this out, you get x squared plus 6x plus 9. And the same thing over here, I've got y squared minus 2y plus 1, which is a binomial squared, which is y minus 1 quantity squared. And over on the far right side, I've got negative 6 plus 9 plus 1, which gives me a grand total of 4. The center is, what are you subtracting from x? What are you subtracting from y? So it's a negative 3 and a 1. That's the center of the circle. This is the radius squared, so 4 is the radius squared, so the radius must be 2.